One of the more powerful data manipulation services in Azure is Azure Data Factory. With this service, you can perform all kinds of actions against your data. Azure Data Factory is a cloud managed service, and that means that this service runs in the Azure cloud and is completely managed by Microsoft. So all you have to do is configure the service to do what you want. But you don't have to worry about all the hardware and software updates and maintenance behind the scenes. What Azure Data Factory does is provide you with the ability to integration all kinds of different data sources. And these data sources can be used as source data or as a destination data source. The whole point of Data Factory is to move and or transform data. And that data really can be from just about anywhere. Data Factory doesn't force you to pull data from Azure cloud sources. You can even configure Data Factory to pull data from on-site sources too. Imagine the power in that. So let's dig into that concept a little bit. Now imagine a scenario where you need to pull data from a client system and then interface with that data somehow. Maybe the purpose of that connection is to migrate data to the cloud. Maybe the purpose is to pull a data set into a machine learning system for temporary analysis. Whatever the reason, the data exists on the client system and needs to be pulled into the cloud, and Azure Data Factory can do that for you. In fact, one of the single most common on site repositories out there is SQL Server. There are countless customers that store their data in SQL Server databases. And that makes sense, right? Customers are going to store their product information in a system that works best with their product. So Data Factory can interface with systems like SQL and pull the data it specifically needs. And the way this works is by creating a data management gateway between the on-prem data source, like SQL, and the cloud service, Azure Data Factory. The gateway acts like a secure data transport layer. But where Azure Data Factory really shines is in the cloud. Azure Data Factory is a cloud native service, and so it's adapted quite well to interact with any other cloud service in the Azure ecosystem. Now, Azure Data Factory is capable of connecting to virtually all other cloud services in Azure. So that includes unstructured NoSQL systems like Azure Storage Accounts or Azure Cosmos DB. But it also includes structured data services too. So that means Azure SQL can be a source for Data Factory. Okay, so that's great that Azure Data Factory can connect to all these different data sources. It's great that it can connect to cloud systems and on-prem systems alike, but so what? What's the point of connecting to these data sources? Well, quite simply, it's about data movement. Well, maybe a bit more than that. Data Factory allows you to perform extract, transform, and load, or ETL operations. And what does that mean? Well, it means that you can use Data Factory to connect to some data source, extract some data from that source, transform the data in some way, and then load the data into some destination dataset. Now, Data Factory can also perform extract, load, and transform, or ELT operations. Well, that sounds like the same thing, doesn't it? What's the difference between ETL and ELT? Well, it's subtle. With ETL, you collect data, transform it, and then load it into a system. Meanwhile, with ELT, you collect data, load it onto another system, and then transform it. Data Factory can help you with both of those operations. Now, ultimately, the way Data Factory does this is by creating data-driven workflows. These workflows define the various steps to execute, their order, and their operations. These steps can include retrieving data, transforming data, moving data around, and various other logical operations. In fact, talking about workflows in Azure Data Factory means that we should talk about the components of Data Factory. A workflow is a very common term. In Data Factory, there are certain components and terminology specific to Data Factory that are all used to compose a workflow. First is a pipeline. A pipeline is the workflow. Pipelines in Data Factory are rendered like a canvas. Users can drag and drop items onto the canvas that dictate the order of various actions to take. And one of the key aspects of a pipeline, or really just Data Factory in general, is the concept of a dataset. A dataset is a pointer to actual data. So let's imagine you had something like a SQL database. In that database, you may have a table or a view or something like that. You can use a dataset object to point directly at that table or view. Then you can use that dataset in your pipelines. Another key aspect of a pipeline is an activity. An activity is an actual step in the workflow or pipeline. An activity can be just about anything. It can be a connector, a transformer, a calculator, and on and on. Activities are organized on a pipeline canvas to dictate the various steps and conditions that the pipeline will perform. Ultimately, the purpose of a pipeline or a workflow is to map data flow. Remember, we're generally talking about ETL or ELT operations, so almost always data factory pipelines are used to collect data and flow it to some other source. Pipelines can add various transformation operations, but at the end of the day, pipelines map the flow of data from some source to some destination. But pipelines can also include control flow activities too. Pipelines don't have to just blindly move data from one location to another. They can also make decisions on what to do under certain conditions. So, for example, if the data being collected has a certain severity rating, let's pretend, then maybe it also gets copied to an event hub so that other services can take more immediate action. Now, another component of Azure Data Factory is what's called a linked service. A linked service is a connection to another service. So, if you want to connect to a particular SQL database, for example, you'd create a linked service connection to that SQL database. And datasets require a linked service to be created first. And the final component we'll talk about is triggers. A trigger is exactly as it sounds. You can configure a pipeline to execute based on some sort of defined trigger. This includes common techniques like scheduled or event driven. So the simplest trigger would be to configure the pipeline to execute on a recurring 10-minute schedule. So you can see that Azure Data Factory can be pretty powerful. So lastly, let's talk about how we would go about actually using it. Well, the very first thing anyone would do is establish a connection to the various data sources involved. And this is done by first creating a linked service, and then you can create data sets to use in pipelines. Then, in those pipelines, you can create activities that will transform, augment, or otherwise enhance your data however you want. Now, one of the cool things you can do with Azure Data Factory, although it is optional, is to use Azure DevOps and GitHub repositories to manage your workflow. And that's extremely valuable because it means that you can version control your pipelines and deploy them using industry standard mechanisms like CI/CD, or continuous integration and continuous delivery. Anyway, with connections and pipelines in place, you'd next make sure that your pipelines are executing. So the last thing you do is monitor your pipeline executions. And Azure Data Factory includes features that allows you to see executions in progress and even past executions so you can validate that everything is working as it should and then troubleshoot if your pipelines aren't running properly. In Azure Data Factory, there's the concept of an integration runtime, or IR. IR is the underlying compute infrastructure that Data Factory uses to execute your workflows across different networks. And there are a few specific capabilities that IR facilitates. For example, data flow is a simple capability. Really, here we're talking about collecting data. Now, that's not to be confused with data movement. Data movement is about copying data between different data stores across networks, like cloud and on prem. So, this isn't just data flow, it's more like a data copy. Movement also includes transformation services, too. Now, another capability that IR enables in Data Factory is Activity Dispatch. Activity Dispatch is about actually executing transformation activities on various other services like Azure Databricks, Azure HD Insights, Azure Machine Learning, Azure SQL, and so on. And finally, we have SSIS package execution, and that's primarily about executing SSIS packages in a managed Azure compute environment. Now, in Azure Data Factory, there are a few elements that are absolutely key to the actual operation of any given workflow. The first is an activity. An activity is a step in the workflow, and there are lots of different activity types. Some are simple and some can be quite robust. But the point of an activity is to define a particular operation that you're performing against your data. For example, you can implement a single activity that can collect data from a storage account and copy it to another storage account. The next key element is a linked service. A linked service contains and manages connection information and even the actual connections to your various data sources. So if you define an activity that will copy data from one storage account to another, then you'd need a linked service defined for each of the storage accounts. And then there are integration runtimes. An integration runtime is actually the thing that provides the bridge between the activity and the linked service. You don't really have to configure any of these, but these integration runtimes are how Data Factory knows how to communicate to a particular data source. Now, obviously, talking to SQL Server is very different than talking to a CSV file. The integration runtimes handle that communication. So, if integration runtimes are handled behind the scenes, then why bring them up? Well, because if there's one thing any data scientist knows, it's that every data source is different. So, what happens if there's some data source that Data Factory doesn't have an integration runtime for? Well, the good news is that Data Factory has you covered there. In fact, you can use the Azure Data Factory web portal to create your own custom runtimes. And the web portal includes a management section that allows you to view existing integration runtimes and even add your own if you need to. All right, so let's say we wanted to create our own integration runtime. Well, if you did want to do that, then you'd have to first pick a type of integration service. And there are three fundamental types that you can choose from, and each type has various capabilities that it can perform. The first is Azure. Now, Azure IR can perform data flow, data movement, and activity dispatch. Then there's self hosted IR. Self hosted IRs can perform data movement and activity dispatch, but they can't perform data flow. And lastly, there's the Azure SQL Server Integration Services, or SSIS IR. SSIS IR is really about configuring SSIS package execution. Now, Azure Integration Runtime can really only perform a certain set of activities, and that makes sense. The purpose of an IR is to be able to understand a particular data source. So, like any good piece of software, it should do one thing and one thing well. So, what are these activities that an IR can perform? Well, first is that it can execute data flows using Azure. Using an IR should allow you to be able to connect to a data source and collect data from that data source. The objective of the data flow activity is to be able to flow data to and from that data source. A similar activity is the ability to execute copy actions between data stores. Now, this is different from flowing data because it can include various other conditions. It also means that the data is being collected and copied from one place to another versus just flowing data as it's seen. And finally, an IR should be able to perform certain transformation activities. An IR will be activated by various activities in a pipeline. So, as an example, there are activities that perform transformation against HD Insight, Azure Machine Learning Studio, Data Lake, Databricks, and so on. But earlier in the course, we talked about how data can flow from both cloud services and on premise locations. And that means that networking is an important aspect to Azure integration runtimes too. Specifically, an IR needs to connect to data stores and computing services that have publicly accessible endpoints. But if you use virtual networks, you can also use an IR to connect with private endpoints in their data stores and computing services. Now, this would allow you to connect to data sources in different and private networks. So that can include on-prem networks too. And lastly, let's quickly talk about resources and scaling needed in Azure integration runtimes. First, IRs are run in a completely managed and serverless compute system in Azure. And that means that you don't have to worry about provisioning hardware, managing updates to underlying software, or handling scaling at all. IRs are really about data movement. So it's important to know that the data movement operations are secure, reliable, and highly performant. In fact, Azure can elastically scale the data movement operations based on demand and load. And finally, activity dispatch with IR is a lightweight operation for routing actions on the underlying compute system. So there's no need to scale compute for dispatch actions. Now, as we've discussed so far in this course, Azure Data Factory can be used to manage data flow. You can use it to do anything from simple data flows to highly complex conditional data movement and transformation. At the end of the day, the way you do that is by defining a workflow. And a workflow is defined using two main components. The first is a pipeline. A pipeline is the definition of your workflow. It has a name, of course, but it can also have triggers that tell the system if and when to run the pipeline, and it provides a nice, simple drag and drop canvas mechanism to define your workflow. The next main component is an activity. An activity is a step in the workflow, or in this case, the pipeline. Activities define what's going to get done at any point in the pipeline. So this can be the data collection, manipulation, or any other host of conditions that you can apply. But if Azure Data Factory is primarily used for playing with data, Then where's the data? Well, you're right. One of the major components of Azure Data Factory is datasets. Datasets are a named view into your data. In fact, datasets point to specific data. For example, imagine a SQL database with a bunch of tables and views. Well, a dataset would be the pointer to one of those tables or views. Now, datasets aren't really part of a pipeline on their own, as in you don't really drag a dataset onto a pipeline canvas. Rather, they're referenced by the activities that you put onto that pipeline. So that's why a dataset isn't really a workflow component. Now, it's important to mention that there's a caveat to datasets. Remember I said that they're like a pointer to specific data? Well, the example I gave is that a dataset points to something like a table or a view in a SQL database. But what about the SQL database itself? Well, that's where linked services come in. A linked service is the actual connection to the data source. It's the link that the data factory uses to connect to a particular data source. So, in our example with a SQL database that has tables and views, the linked service is the connection to the SQL database, and the data sets are the pointers to the tables and views. Now, linked service is where you actually define the connection to external resources like SQL, storage accounts, Databricks, HD Insight, and so on. Okay, so let's see if we can pull all of these concepts together. Now, consider the image on the screen. Let's actually go right to left on this. On the very far right, we have a pipeline. Remember that a pipeline is effectively the definition of our workflow. So, put simply, it's a logical grouping of activities. And that brings us to the activity box in the middle. And you can see that it really is central, isn't it? Activities are contained in pipelines, but they're also interfacing with datasets and linked services. An activity can run on a linked service. That's not always true, but depending on the operation the activity is performing, it may have to execute on the linked service. Certainly, it will minimally execute against a linked service. And as you can see, the activity also interacts with datasets. Now, activities can perform operations against datasets, so they need to consume those datasets. But an activity can also produce a dataset. So consider a copy operation. In that scenario, it's going to consume the source dataset and then produce an output copy dataset. And that brings us to the dataset box on the far left. Remember that a dataset is a pointer to some data, but that data comes from a particular data source, and that data source is managed by the linked service. So you can see from the image, dataset represents the data stored in the linked service. Now, lastly, let's talk about how we would work with linked services. First, and probably most critically, we use Azure Data Factory to create linked services. Now, this is done through the management view of the Data Factory web portal. But technically, you don't have to use the web portal. Azure Data Factory actually provides APIs and SDKs and all sorts of other things that you can use to perform these types of operations using any programming or scripting tool that you might like. Linked services are also obviously used to connect to your various data stores. But it's important to understand that not every data store in the world is supported by linked services. So Microsoft has a shared list of supported data stores. And it's a good idea to go and check out that list just to make sure that your data store is supported. And even if it isn't, you can always try to create your own connection. And lastly, there's the concept of computing linked services. Now, computing linked services are used to reference compute environments that you can connect to from your data factory. Now, you can configure these connections in lots of different ways, though for the most standard data movement activities, this type of linked service probably isn't very common. Let's talk about pipelines in Azure Data Factory. First, it's useful to note that a single implementation of Azure Data Factory can have as many pipelines defined as you want. Now, the purpose of a pipeline is to define a workflow, and workflows have steps. In Azure Data Factory, a step is implemented as an activity. So a pipeline provides a mechanism to logically group and order activities. The logical grouping or managed grouping of activities lets a pipeline execute a familiar or at least necessary workflow. And we'll talk more about that in a second. The last important aspect about pipelines is that they can be triggered in a variety of different ways. First, they can be triggered either based on some event or as a result of a schedule. And once fully configured, a pipeline can be deployed and execute the workflow for real every time the trigger fires. Now let's go back to that activity grouping. A pipeline allows you to add activities using a simple drag and drop interface on a canvas. Activities represent the steps in your workflow. But what are some of the things that activities can do? Well, there's actually a wide array of things that activities can do, but let's stick to the main three archetypes. The first major thing that an activity can do is define data movement. If you have the need to have data flow from one place to another, you can use an activity to do that. For example, imagine you wanted to flow data from a SQL database to a data source being used by an Azure Machine Learning Studio instance. Well, you could absolutely use an activity to do that. Now, another thing you can use activities to do is data transformation. Now, data transformation is extremely common. More often than not, there's data in a data store that you want to use in some operation, but you need that data to be augmented somehow. For example, I've collected process data from tons of different sources, but in the majority of the actions I perform, I need that data to be formatted in a simple timestamp value format. Well, you can use a data transformation activity to convert that input data to a completely different format that you can then use. And the last major thing an activity will do is control flow. Basically, this is about conditional operations. For example, let's pretend you wanted to inspect some incoming data, and if that data contains a certain characteristic, you want to flow a copy of that data to a special location for additional analysis or even alerting. Well, using conditional logic in your activities, you can absolutely do that. Now, Data Factory wouldn't be much of a data service if it didn't, have data. Well, one of the most important components that activities interface with is datasets. Now, datasets can be used as either input for activities or outputs. Most activities generally accept a dataset as their input. Now, depending on the activity, an output dataset will then be generated. So, as a simple example, imagine a copy activity. That activity is designed to copy data from one location to another. So the input dataset would be completely copied, and then an output dataset would be generated as a copy. Now, since a copy activity generally also has a reference to a destination dataset, usually referred to as a sink, then the generated output dataset would then be flowed to that destination. And don't forget that a dataset is really just a pointer to some data in a particular data store. So datasets are used to identify data in those data stores. The actual connection information to the data store is managed by linked services. Now, many activities in Azure Data Factory are used to manage the movement of data from one location to another. And I gave the example of the copy activity that copies the contents of a given input dataset to a given destination dataset. For data movement activities, Data Factory supports lots of different data stores. For example, virtually any Azure data store is supported by Data Factory. So that includes storage accounts, Cosmos DB, Data Lake, MySQL, Databricks, file storage, SQL, Synapse, and so on. But external databases are also supported. So if you have data in systems like Amazon Redshift, Google BigQuery, HBase, Hive, Apache Impala, Oracle, MySQL, Spark, Sybase, and more, then you're probably covered. Most NoSQL databases are also something that Data Factory can interface with, and this includes systems like Cassandra, Couchbase, and even MongoDB. And if you've been around as long as I have, you'll know that there's lots of customers that just can't resist storing certain information in files too. But that's okay because Data Factory includes all sorts of file-based access too. And that includes big things like Amazon S3, FTP, Google Cloud Storage, HDFS, Oracle Cloud Storage, and more. Even generic protocols are supported. So if you want to perform operations against ODBC, REST, or OData, Data Factory can support that too. And you can even use Data Factory to connect to certain third-party services and apps. For example, Amazon Marketplace, Jira, Google AdWords, Microsoft 365, PayPal, Salesforce, SAP, Shopify, and more. Now, the important takeaway here is that activities in Data Factory are very powerful. Activities can be used to perform all kinds of data transformation operations. They can be run individually in a pipeline, or they can even be chained together. And that's pretty cool. You can have an activity that collects data from an input dataset, augments it, then produces an output dataset that can then be used as an input for another activity that augments it again. And you can make that chain as long as you want. That can be very handy for situations where the augmentation of data is complex and requires multiple steps. In fact, I once had to pull together a 12-step augmentation workflow to convert standard process data for an oil and gas company into usable contract data. But activities can also be used to control flow, and there's lots of different operations in a control activity can perform. They can be used to manage variables, implement an if-else gate, run a loop, perform a lookup, wait for a period of time, connect to a web service for information, apply webhooks, and on and on and on. Now, interestingly, a pipeline with all of its activities can be rendered as a block of JSON, and we'll talk more about that later. So, as I implied in my chaining example earlier, it's important to note that you can have as many activities as you want in a pipeline. Activities can be chained together by creating dependencies, and that means that activities won't run until their dependencies have run. But activities don't have to be chained. What I mean is that activities don't have to be dependent on other activities. What that means is that you can actually have activities run in parallel. And lastly, we'll talk about pipeline scheduling. Pipelines are scheduled by using triggers. Well, there's basically three types of triggers: manual, scheduled, and event driven. A manual trigger doesn't really have a definition per se, it just means that you can execute your pipeline whenever you want. If you do that, it'll be classified as a manual trigger. A scheduled trigger executes your pipeline whenever a certain time condition occurs. So if you wanted to run your pipeline every 15 minutes, then that'd be a scheduled trigger. And lastly, there's an event-driven trigger. Basically, that allows you to have your pipeline execute when a certain event occurs. Now, that could be the presence of data in a database, or an event in Event Hub, or it can even be an actual event in an event grid message. In Azure Data Factory, we define pipelines to represent our workflows. Once a pipeline has been defined and configured, it can be run. So let's talk about pipeline runs. Let's start with the definition. A pipeline run is an instance of a pipeline execution. So let's say that you opened up your pipeline and selected to manually run it. Well, that execution would be logged as a pipeline run. A pipeline can be configured with input parameters too. So when a pipeline run is performed, it can be invoked by passing in specific arguments. And that means that you can have pipeline runs that are different based only on the input parameters. For example, imagine you wanted to run a pipeline that looked at a static data set and performed particular aggregate operations depending on the input parameters. In that scenario, I could execute the same pipeline on the same input data, but get one output with sums, one output with averages, and one output with standard deviations, all based on input parameters. Now, pipeline run also includes information about how it came to be run. A pipeline can be executed manually or through other types of triggers. So when you inspect a pipeline run, you'll be able to see what type of trigger actually executed that pipeline. Now, if you wanted to execute a pipeline manually, you actually have a number of different options available to you. Obviously, you can use the Azure Data Factory web portal to do that, but there are other ways too. For example, you can actually use Azure PowerShell to connect to your Data Factory and execute the pipeline. And there's two ways to do that. You can use the PowerShell terminal built right into the Azure web portal, or you can run Azure PowerShell directly on your system. Now, the advantage of PowerShell is that you can create a reusable script. You can also use a .NET SDK to connect to the Data Factory. And this gives you enormous control because then you can create your own custom applications or service with your own logic. Now, depending on whatever your conditions are, you can eventually trigger the pipeline. But the problem with the .NET SDK is that it's .NET. So what if you aren't in a position to use .NET? Well, fortunately for you, Data Factory includes a REST API. And as long as you're using a programming language that can connect to a REST API, then you'll be able to interface with Data Factory and execute your pipeline. Heck, you can even use Postman. But if scripting is more your thing, then you can use Microsoft's Python SDK to interface with the Data Factory as well. Now, as I said, you can also use triggers to execute a pipeline run. These triggers are typically schedule-based, but they can also be event-based if needed. Triggers basically represent a unit of processing. They determine if and when a pipeline needs to be executed. So consider a scheduling trigger. We want to execute a pipeline every 15 minutes, let's pretend. Well, the trigger is always watching to determine if the appropriate time has happened yet. And if that 15 minutes has expired, then it triggers the pipeline to run. In other words, the trigger is the declaration of the condition for when, or even if, to execute the pipeline. So let's talk about pipeline triggers. Azure Data Factory actually includes three main trigger types. First is the scheduled trigger, and this is the most intuitive. With a scheduled trigger, you can define the specific time when a pipeline will get executed. You can make this a one-time run, or you can set up recurrence. Recurrence is probably the most common, actually. You have a lot of options there, too. You can set up your pipeline to run every minute to every few months if you want. And then there's the event-based trigger. With event-based triggers, a pipeline will execute when certain events happen. So this could be as data appears in a database, as data appears in an event hub, or even as an actual event appears in an event grid. In my opinion, event-based execution is best because it means you know you're executing in response to changes in the system. But with a scheduled trigger, the state of the system may be exactly the same as the last run, so it's possible you get no new answers. But each has their pros and cons. Now, lastly, there's the tumbling window trigger. A tumbling window trigger is like a scheduled trigger, but the big difference is that there's always a fixed size with a specific start time and they retain state. So imagine you wanted to run your pipeline at the start or end of every month. For that, you'd use a scheduled trigger because the size of each window would be different. Some are 30 days, some are 31, and some are even 28 or 29. If you wanted a schedule that executed actually every 30 days, then you'd use a tumbling window trigger, but that would not line up with the end of every month. Now, triggers are something that you can create in Azure Data Factory. They're associated with pipelines, but they don't belong to pipelines. In other words, triggers and pipelines have a many-to-many relationship. And what that means is that multiple triggers can be defined and associated to a single pipeline, and any one of them can result in the execution of that pipeline. Meanwhile, a single trigger can be used by multiple different pipelines. So when that trigger fires, perhaps multiple pipelines will actually get executed. Now, pipelines, activities, and triggers are non-temporal. They're all definitions of something and they don't change over time. What that means is that they can be represented by a static definition file like JSON, and that makes them ideal for storage in a repository for version control. So in the case of a scheduling trigger, you can have simple properties in that JSON file. For example, the start time property would naturally include the time at which the schedule should begin. And you can set this in the future if you don't want the trigger to start until some time later. The end time property states when the trigger is no longer valid, and that can actually be left blank if you don't want it to ever end. The time zone property is important to give some meaning to the given timestamps, and this is especially important if you consider daylight savings time. Recurrence is just that. With this property, you're really defining whether this pipeline will run multiple times. If this value is set, then the frequency and interval properties are required. Otherwise, they aren't. And in fact, the frequency and interval properties indicate the actual recurrence schedule. So you can use these properties to state that the pipeline should run, for example, every 15 minutes. But there's also a schedule property that can be used to contain modifications for the recurrence. But that's getting a bit more advanced. In this demo, we're going to provision our own instance of an Azure Data Factory. To do that, we're going to use the resource creation process in the Azure web portal. And once we've deployed the Data Factory, we'll explore the service a little bit. Okay, so the first thing we need to do is head over to the Azure web portal using our browser. Good. Now, Azure Data Factory is a resource, just like any other in Azure. So in order to provision our own instance of Data Factory, we need to create a resource in Azure. Now, at the top of the screen, select the Create a Resource button. Good. Now let's search for Data Factory in the search field of the Create a Resource screen. Excellent. Now let's find Microsoft's Data Factory item in the result list and click the Create button. Perfect. Now we see the Create a Data Factory page, and this will guide us through the creation process of our Data Factory. In fact, this is a lot like a wizard. Now at the top of the Basics tab, we're being asked to select a subscription and a resource group. Now you can put this resource wherever you want, but it's generally a good idea to put resources in an easily controlled resource group at least. So for example, I'm going to create a new resource group called RG-SB Demo 11. Now, the reason I'm doing that is because when I'm done, I can just delete the entire resource group and all the work I've done can be cleaned up quickly and easily. Now let's name our data factory. I'm going to keep it simple and name my data factory SBDemo11. Now we're going to leave the rest of the options on this page as their defaults. But now let's click Next at the bottom of the screen. Now this screen is allowing us to connect our data factory to a Git repository. And this can be extremely handy if we want to make sure that the pipelines and activities that we perform in our data factory are historized, controlled, and maintained in a version control system. For demo purposes, we really don't need that, so let's make sure the Configure Git Later checkbox is checked. Good. Now let's click the Review and Create button at the bottom of the screen. All right. Now, assuming your settings pass all of Azure's review processes, go ahead and click the Create button at the bottom of the screen. Excellent. Now, this kicks off the creation process, and Azure Data Factory isn't a very complex service on its own, so there's not a lot to provision. So let's just wait for it to be completed. Great, our resource has been created already. Perfect, so let's go ahead and navigate to it by clicking on the Go To Resource button in the middle of the screen. Excellent. Now, as you can probably tell, Azure Data Factory is an extremely simple resource by Azure standards. There aren't a ton of options in the left-hand menu. In fact, the options listed are pretty much just the standard Azure items. So that includes being able to grant access using the access control option, setting up alerting or metrics in the monitoring section, and issuing support requests all the way at the bottom of the menu. But that's because the magic of Data Factory is not performed in the standard Azure web portal. The magic happens in the Azure Data Factory web portal. Now to access that, let's click on the Author and Monitor button in the middle of the page. Now if you're prompted to sign in, go ahead and do that. All right, now we're talking. So this is the Azure Data Factory web portal. Now right in the middle of the screen, you can see a few options right away. With a simple click of the relevant icon, we can use our instance of Data Factory to create a new custom pipeline, create a data flow from one location to another, create a new pipeline based on a template, copy data from a location to another, configure SQL Service integration services, or even set up a code repository for all the work that we're doing. Now below these icons are a few video tutorials to get you started with some common activities too. In fact, if you keep scrolling, there are some actual tutorials for various specific scenarios you can walk through as well. Now at the very bottom of the screen, there are links to some additional resources too. Meanwhile, along the left-hand side of the screen, there are 4 icons. The top icon, the Home button, takes you to this screen. The second icon is for authoring. In fact, let's click on it. Now, as you can see, we're presented with a dashboard that we can populate with items from the Factory Resources section. And we'll deal more with this in later demos. The third icon in the menu is for monitoring. So let's click on that now. Now, this screen lets us watch our pipelines and their run statuses. If there have been any issues, we can see that in this screen as well. We can even configure alerting if we want. And the last icon in the menu is for managing our data factory. Let's click on that. Now in this screen, we configure linked services, our Git link, ARM deployments, triggering, and access keys. And we'll be touching more on this section in later demos as well. Okay, now with the data factory, we're going to want to move data from one source to another. So let's create a simple Azure storage account with a blob container. We'll use this storage account as both our source and our destination. So to do that, we need to flip back to our Azure web portal in our browser. Good. Now let's select the Create a Resource link in the Azure menu in the top left. And now let's search for and select the storage account resource type. Good. Now we're going to be happy with most of the defaults here, so let's just get this needed parameters set up. Now at the top of the Basics tab in the Creation screen, let's select the same resource group that we created with our data factory. Good. Now let's scroll down and give our storage account a name. I'm going to call mine SBDemo11. And now let's select locally redundant storage in the redundancy selection to keep things as cheap as possible. Good. Now let's click Review and Create. And now we can click the Create button. Now the creation process may take a minute or two, so let's wait for it to complete. Good. Now what we want to do is create a blob container. So let's go ahead and click on the Go to Resource button so that we can navigate to our storage account. Now let's click on the Storage Explorer option in the left-hand menu. Perfect. Now let's right-click on the Blob Containers section and choose Create Blob Container. Perfect. Now let's name our blob container something. Now, I'm going to call mine something real simple, like BlobCon for blob container. Good. Now let's click Create. Now let's make sure it's there by expanding the blob containers section. All right, it is. Now let's click on it. Good. Now what we're going to do later in this course is we're going to use Data Factory to move data around in this container. So let's get our system prepped for that. First, let's click on the New Folder button. Now let's name the folder Source. And let's click OK. Good. Now in the toolbar, you'll notice that you've actually automatically been navigated to the source folder. So let's click on the root, in my case, BlobCon. And now let's create another folder called Destination. And click OK. Perfect. And one more time, let's make sure we're back on the root. Now we're going to do one more thing. We're going to upload a test file to our source folder. First, let's open up Notepad. Now let's put some names in here. I'm going to type Jones, Alice, and then on the next line, I'm going to type Johnson, Bob. Good. Now I'm going to save this file as names.txt. And back in the browser, let's click the Upload toolbar button. And let's browse for our file. And we'll select it and click Open. And now let's expand the Advanced section. And under the Upload to Folder field, let's type source so that it'll go into our source folder. And now let's click Upload right at the bottom of the screen. Perfect. Our file has been uploaded and you can see that it's in the source folder. Excellent job. Great stuff. Now we've now created a storage account, we created a blob container, we created some folders in our container, and provisioned our own instance of Azure Data Factory. We also took a look around the Data Factory web portal to get our bearings. So in our next demos, we'll use Data Factory to play with that data and our storage account. Great job! In this demo, we're going to create a linked service and a data set in our instance of Azure Data Factory. To do that, we're going to use the Azure Data Factory web portal interface for our already deployed Data Factory and connect to our storage account. All right, so like I said, in our last demo, we provisioned an instance of Azure Data Factory and a storage account. So in this demo, we're going to use the Azure Data Factory web portal to interface with our new Data Factory and connect to our storage account. So let's open the Data Factory web portal in our browser. What we want to do in this demo is we want to configure our Data Factory in preparation to move some data from one part of our storage account to another. In other words, our storage account is going to be both the source and the destination for a copy activity. Now, the first thing we're going to want to do is create a linked service. So let's click on the management icon in the left-hand menu. Good. Now notice that the linked service section is already selected in this part of the portal. A linked service in Data Factory contains connection information that Data Factory can then use to connect to another service at runtime. So let's create a linked service. Let's click on the New button at the top of the screen. Good. Now in this list, we're seeing a ton of potential sources for a linked service. And this shows you that you can get data from just about anywhere, and that's pretty impressive. For our purposes, we want to go to the blob container that we created in the storage account we provisioned in our previous demo. So let's find and select the Azure Blob Storage item. And now we'll click Continue at the bottom of the panel. Good. Now let's give our linked service a name. I'm going to make sure it matches the blob container I created in the last demo, so I'm going to call my linked service BlobCon. Good. Now notice that we've left the authentication method as the default account key, and this means that our linked service will connect to our storage account using an account key rather than something like a managed identity. Anyway, let's select the subscription our storage account lives in. And now let's select our storage account in the storage account name field. Perfect. Now let's test this by clicking on the Test Connection button at the bottom of the panel. Nice. Since everything appears to be good, let's click Create at the bottom of the panel. Perfect. We now have a connection to our blob storage in our data factory. Next, let's create a couple of data sets. Now, these data sets will map to our source and destination folders that we created in our blob storage account. To create data sets, we need to go to the authoring section. So let's click on the authoring button that looks like a pencil in the far left portal menu. Good. Now, to create a data set, we need to create a factory resource. To do that, we need to click on the plus button beside the filter field. And in the list of options, let's choose Dataset. Excellent. So once again, we're presented with a panel where we can select from all kinds of different potential data sources. Now, the data we're going to be playing with is in our blob storage container. So let's start by selecting Azure Blob Storage from the list and clicking Continue at the bottom of the panel. Good. Now it wants us to choose what kind of files we're dealing with. Now, if you recall, our names.txt file that we stored in our blob container in the previous demo is really just a simple text file. So we actually want to choose the binary option because that option makes sure to leave the file exactly as is without any processing whatsoever. So let's select that option and click Continue. Perfect. Now it wants a name for our data set. Now we'll use this as our source data set, so let's name it Source. And look at that, it wants us to select the linked service where we can find the data for this data set. So let's choose our linked service from the list. And now we're presented with a set of fields to filter our data set to only a certain container or folder. Perfect, that's exactly what I want. Now at the end of this line, let's choose the Browse button. Now this lets us browse to our names text file, so let's do that. Perfect. Now that we've got this filtered how we want, let's click OK at the bottom of the page. Huzzah! We now have a source data set. Now let's make sure that we save that data set. So at the very top of the screen, there's a Publish All button. Let's click that. Good. Now this panel shows us all of the items that we're about to publish. In this case, it's just our data set. So publishing an item means that it's going to be saved and made available to anyone using this data factory. So let's go ahead and click the Publish button at the bottom of the panel. Perfect. Our data source is being saved, and now it's saved. Now let's create the destination data set. Let's click on the plus button once again to create a factory resource, and we'll select Dataset from the menu, and we'll choose Azure Blob Storage in this list, click Continue. Now we'll select the binary file once more and click Continue. And now this time we'll give this dataset the name Destination. And let's select our link service once again. And this time we're just going to type the container name in the container name field, blobcon. And we're going to type the destination folder name in the directory field, destination. And now we can click OK at the bottom of the screen. Good. Now let's publish again so that we can save our destination dataset. Excellent. Well done. We've now created a linked service in our data factory to our storage account, and then we created two datasets to point to our source and destination folders in our blob container in our storage account. In our next demo, we'll create a pipeline that can be used to move data from the source to the destination folders. Great job. In this demo, we're going to create a pipeline and some activities in our instance of Azure Data Factory. To do that, we're going to use the Azure Data Factory web portal and create a pipeline that interacts with our data sets that we created in the previous demo. Okay, so the first thing we need to do is head over to the Azure Data Factory web portal in our browser. So in this demo, we're going to create a Data Factory pipeline. The pipeline will implement activities that will copy data from one data set to another. In our last demo, we created two data sets. The first was a data set that pointed to our source folder in our blob container in our Azure storage account. And the second data set pointed to our destination folder in the same container and the same storage account. Now our intent here is to copy everything in our source data set to our destination data set, and a pipeline will help us do that. So let's get started. Let's click on the authoring item in the left-hand menu. Now a pipeline is a factory resource. So to create a pipeline, we need to create a factory resource. So let's click on the plus button next to the filter field. Good. Now let's select pipeline from the list of options. Awesome. So now we have a pipeline. Now, on the screen, we're seeing a pipeline designer. On the left are a bunch of activities that we can use in our pipeline, and in the middle is a canvas that we can use to connect and organize our activities in a drag and drop format. And on the right is a panel that can be used to set the properties for the various activities or even the pipeline itself in this case. In fact, the right-hand panel is asking us for some information about our pipeline. So why don't we do that? Let's give our pipeline a name. I'm going to call mine Copy Demo. Good. Now let's close that panel by clicking the Properties button in the toolbar. That'll give us more space. Okay, so as I said, the purpose of our pipeline is going to be to copy data from some source to some destination. We know both the source and destination are blobs, so we're going to use a simple activity to perform that copy. Now in the list of activities on the left, let's expand the Move and Transform section. Now let's drag the Copy Data activity onto the canvas. Perfect. Now notice at the bottom that a panel has appeared that's asking for specific properties about our activity. Well, let's set it up. Let's give our activity a name. I'm going to call mine Copy Blob to Blob. Good. Now let's click on the Source tab. Here it's asking us to choose a dataset. Well, we know we want to copy from our source dataset, so let's choose that dataset from the dropdown. Nice. Now notice that there's all kinds of filters and actions that we can apply to this dataset as part of the copy activity. Now we're going to leave ours as the defaults, so let's click on the Sync tab. Now the Sync dataset is effectively the destination for this activity. We know we want to copy data from our source dataset to our destination dataset, so let's choose that dataset from the list. And once again, notice that there's a bunch of options that have appeared to configure the copy. But once again, we're going to leave it as the defaults. Okay, so that's our pipeline. Pretty simple. Except, how do we even know if it's configured properly? Well, to answer that question, we can actually validate the pipeline. Now, at the top of the screen, let's click the Validate toolbar button. Now, what this option does is go through all the configurations that we've made on our activities and any relationships that we've established. If any of them aren't configured properly, the validator will find those problems and list them. In our case, our pipeline is totally valid, and no errors have been found, so great job. So let's close this panel. Okay, so we've been told our pipeline is valid, but how do we know it works? Well, we want to make sure our pipeline is fully functional before we deploy it to the real world, right? Well, to do that, we need to run our pipeline in debug mode. To do that, we need to click the Debug toolbar button at the top of the screen. So let's do that. All right, so now Data Factory is actually executing our pipeline. So now we can see a pipeline run listed at the bottom of the screen. In that run, each of the activities are listed, and since we only have one activity, that's all we see. Now for each activity, we see a status. And once all the statuses have been completed, we know our pipeline works. And we see succeeded, so we know our pipeline actually completed successfully. But did it do the job that we expected? Well, let's find out. To do that, let's flip over to the Azure web portal in another tab in our browser. And now let's navigate to our storage account. Mine was called SBDemo11. And now let's open the Storage Explorer. And let's go over to our blob container and open it up. Hey, look at that. We now have a source and a destination folder showing. Let's click on the destination folder. Wow, there's our names.txt file. Our pipeline worked. So let's go back to our Data Factory tab. Good. Now that we know our pipeline is functioning properly, let's save it, or rather, let's publish it. Now at the very top of the screen, click on the Publish All button. Now the panel on the right-hand side of the screen shows us all the items that we're about to publish, and for us, that's just the pipeline that we created. So let's publish it. Let's click on the Publish button at the bottom of the panel. Perfect! Our pipeline is now saved. And so there you have it. We've successfully created a pipeline, added a copy activity, configured the activity to copy data from our source folder to our destination folder, validated our pipeline, ran a test execution of our pipeline to validate it, and then published our pipeline. Great job! In this demo, we're going to explore triggering techniques for pipelines in Azure Data Factories. To do that, we're going to use the Azure Data Factory web portal to configure triggers on the pipeline that we created in our previous demo. Okay, so the first thing we need to do is head over to our Azure Data Factory web portal in our browser. All right, so in our last demo, we created a pipeline. Now, before we get started, let's navigate to that pipeline. Click on the authoring button in the left-hand toolbar. Good. Now let's open our pipeline by expanding the pipeline section and selecting our pipeline. Mine was called Copy Demo. Perfect. So here we are presented with our pipeline canvas with a single activity. Now, as a reminder, what this pipeline is doing is executing that single activity. And this activity copies data from a source folder in a blob container in a storage account we created in an earlier demo to a destination folder in that same blob container. Now, in our previous demo, we executed the pipeline in debug mode to validate that it works. In this demo, we're going to create triggers to execute this pipeline. Now, adding a trigger is pretty simple. Actually, let's click on the Add Trigger button at the top of the canvas. Now, notice that we have two options. The first option is Trigger Now, and the next is New/Edit. The Trigger Now option is how you would execute this pipeline manually. With this option, you're saying, I want to execute this pipeline right now. So let's do that, in fact. Let's pick the Trigger Now option. Cool. So now we get a pop-up panel. If we had parameters in this pipeline, we could configure them here. Now we don't have any parameters, so we're good to go. So let's get this show going. Let's click on the OK button at the bottom of the panel. Good. Now at the top of the screen, there's an indication that the pipeline is running. All right, the pipeline completed successfully. Now, it's not always just about sitting here and waiting for things to be completed. There are other ways to see progress. In fact, let's explore that. Let's click on the Monitor item in the Data Factory toolbar on the left. Hey, look at that. The first item in the monitoring menu is Pipeline Runs, and this is showing us all the pipeline runs in the last 24 hours. And there's our run. It even says it was triggered manually. And it says it was successful. Nice. Now let's try a different kind of trigger. Let's navigate back to our pipeline. Now let's click on the Add Trigger button once again. And this time, let's click the New/Edit option. Cool. Now the panel on the right-hand side now shows us all the triggers that we have configured for this pipeline. And it happens to be empty, so not much surprise there. Now, what we want to do here is we want to create a scheduled trigger. We want our pipeline to execute on a regular interval. So let's set that up. In the Choose Trigger pull-down, let's select the New option so that we can create a trigger. Cool. Now let's give our trigger a name. I'm going to call mine Every Minute. Good. Now let's configure the recurrence. Let's set the value to 1 minute. Good. Now we can leave the rest of the options as their defaults. Now this trigger is now set up to execute every minute starting basically right now and forever afterwards because we don't have an end time. So let's save this by clicking OK at the bottom of the panel. Good. Now we're being asked to set parameters, but once again we don't have any parameters, so we can zip right past this page. So let's click OK at the bottom of the panel once again. Excellent. We now have a scheduled trigger. Or do we? Now we created a trigger which modified our pipeline, but we haven't actually saved those changes. We didn't publish the pipeline. So to do that, we need to publish our changes. So let's click on the Publish All button at the very top of the screen. Perfect. And now notice that it's showing us that we're going to be saving a new trigger, and that's right. So let's click the Publish button at the bottom of the panel. Good. Now we have a trigger. So let's find out how true that is. Let's flip back over to our monitoring screen. Good. Now remember that this screen shows us a list of all of our pipeline runs. And since we're expecting a run every minute, let's sit on this screen and refresh the list periodically for a few minutes. And I'll fast forward that through you so that it's not so boring. Awesome. So there you have it. Throughout our demos, we created an instance of an Azure Data Factory. Then we created a linked service in the Data Factory that pointed to a storage account that we created. Then we created two data sets in Data Factory. The first pointed to a source folder in a blob container, and the second pointed to a destination folder in the same blob container. And then we created a pipeline that copied data from our source folder to our destination folder. We validated and debugged the pipeline to make sure it was configured correctly and working. And then in this demo, we played with triggers to make sure that the pipeline executed whenever we wanted it to. Great job! Now, before we go, just as a reminder, if you created a resource group to put all of these demo resources into, you can now go ahead and delete that resource group to clean up all these resources so that you don't take on a bunch of cost. Happy data transformation and happy data movement. So in this course, we've examined Azure Data Factory and its features. We did this by exploring Azure Data Factory integration runtime and how it works, linked services, datasets, triggers, pipelines, and activities in Azure Data Factory, creating an Azure Data Factory linked services and datasets, and creating Azure Data Factory pipelines and triggers. In our next course, we'll move on to examine Azure non-relational data types and stores.